Right. Hello and welcome, everyone. Today, I don't have a complete lecture prepared, but instead, what we're going to do, instead of going through a PowerPoint, we're going to go through and look at the BLASTWIN help file, which has been provided by Dr. Zach Adjutantis at the University of Kentucky. It's being provided free of charge. And while it's not specifically designed for actual design purposes, in the sort of information about the file, you'll see that it is instead for students that are studying blasting, so that they can work through some of the many empirical equations that are out there, that some of which we just talked about last week. So, with that, we're just going to scroll through here and point out some of the features of the program and what it can do. Here you have an overview of the table of contents, the overview of the program itself. We'll then talk about briefly about the file menu. The input menu is more important, which contains the calculations that you can do with the program. The utilities menu, and then, of course, this is the help file. So here we are. So really, this works like pretty much just any other Windows program out there, that you can create new files, you can open existing files, save files, setting up your printer, that sort of thing, browsing text files, and of course exiting the program. You would just use the new option to create a new data set. Of course, open would open a file, save a file, that sort of thing. I don't know that we'll be needing to print anything for this, so I'm just going to skip that. You can view a text or an ASCII file using the program. You cannot edit it, but you can read it. And then, of course, you just exit the program normally. But now, part 3, what we really want to get into here. It does allow you to enter a project description. You can enter anything there you'd like, maybe the name of the mine or the name of the pit that you're analyzing or something like that. And then we get into burden calculations. So if you remember, we covered a couple of these from the mining engineering analysis textbook. One of those equations is covered here in the first two: the Anderson equation, the Ash equation. There are others here listed which have different input parameters and maybe better suited to certain characteristics or geology than others, but there are several you can choose from. And then you have blast calculations. That option allows the user to calculate several parameters used for blast design, either through the burden calculations that we just mentioned, or you could just enter that in. And then parameters directly depending on the burden, such as stemming and sub-drilling, can be calculated either as a function of blast hole diameter or as a function of burden. You can do it either way. And the program will count the optimum blast hole configuration. And that's based on the minimum difference between the production level that you desire and the actual production value. So as soon as those are as close as possible, it says this is the optimum configuration. Okay, there's also a menu option to allow for vibrations, damage based on vibrations from a number of international specs. And then finally, the utilities menu then allows you can either clear the history of a window, you can close and restore history windows, and then of course, and copy it as well. So then you paste it into, any other program that you might need it. Settings, there are default controls for most of those. The settings, you can change units. You can change the input file or the extension for the input files. Data path, disclaimer that's displayed every time you load the program. You can turn that off if you want. I just leave mine on for, I guess, no reason other than to just be reminded every once in a while. Reminder of annual updates. If they are indeed annual, they probably are at the moment. But in the future, they may not be. And it'll just be as they come out. Lots of other stuff in here, just the settings that you can change. And finally, there's an example of a BLASTWIN input file. Options, English menus. Yeah, I'm going to keep it set to English for myself and probably recommend everyone else do the same. Show all BLAST design solutions. If this option is enabled, then the program will display all BLAST design solutions instead of just the optimum. Okay. So you can just get them all that way. Whenever burden calculation formulation is accessed to the date. BLAST design menu, warning will display the settings. Okay. Warning. Unit conversions for 4 types of units. Pressure, length, stress gradient, load gradient. You can convert the units of the file back and forth. Part 5, and then the help menu. So this is the help file in PDF format. It's also available in the program. Here it says that it was created by Thomas Villas and Professor Zach Adjutantis, the Technical University of Crete, and the University of Kentucky, I will say so. Here we go. And of course, you have figures as well, which aren't anything. And that's it. So that's just a brief introduction to this software based on the help file and what it can and can't do and what it's used for. Like I mentioned, this is mainly for you, the students, to basically use some of these equations in a software format to get a better understanding of how surface blasting works. So with that, we'll pick this up later on, and I'll go through some of the steps that you can go through to use this software. Okay, so we've closed out of the help file, and we're now going to open up the program itself. I have an icon here on my desktop. Oh, it's the wrong one. Let's not do that. Let's do this instead. BLASTWIN. There we go. Here's the disclaimer. So it pops up unless you turn it off in the settings. So saying the software is provided as is without warranty of any kind, including expressed or implied warranties or marketability or fitness for a particular purpose. Blah, 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 blah. Some other stuff. You cannot sue the developer. So that is the disclaimer. There we go. So there it is. It's got a nice blast photo on the front. Oh yeah, it opened twice. Yeah, that's my laptop for you. Okay, so here we go. Of course, once again with the file menu, this is where you save and open files and all that sort of thing. But where we really want to go here is the input menu. So we're going to bring the project description up. You can type in anything you want here, and it's just to describe the project. And you'll see the current units is selected as mixed. Okay, so in the settings, I already have it set to English units because that's what I'm most familiar with. But because some of these equations are empirically based, they might be based in metric units, as you'll see. So that's why it says mixed here. The results are going to be in English units. However, Some of the input will be in metric here, as you'll see. So, burden calculations. If you remember, there's several, 7 in fact, empirical equations to determine the burden in blasting. You can start with Anderson, and this determines your borehole or your burden based on the diameter. So we'll try a popular, so a 9-inch hole here, and then for the borehole length, let's just go ahead and say that's about 80 feet there. So with this, you can calculate your burden to be 26.83 feet. Okay. What about ash? Now, I don't know what our burden coefficient is, but let's put in 9 here. Oh, okay. I didn't mean to put in a blank field. I was trying to type 9. There we go. A 9-inch hole. And then if your burden coefficient is 25, it is an effective burden of 19.13 feet. However, if we remember correctly, I think the average was about 30 here. So let's put that in. That bumps it up to 22.5, and then 35 gets us up to 26.25, and that was sort of the range of the burden coefficient. You can calculate it here if you have the rock density and explosive density plus references for those, and then also the velocity of detonation. So we put those in here. You can calculate what the actual burden coefficient for your parameters are for the area that you're working, and then go back to here to calculate the effective burden. We also have a number of other equations. For example, now this is in metric units, as you'll see. So if we take that same 9-inch hole diameter and we do a little bit of quick math here, so 9 times 52.4 will give us 471.6 diameter blast hole. Length in meters, so if we do the same 80, we divide by 3.28, we'll get 24.4 meters. Okay, guess we'll have to. 24 is outside of the input range. Oh, okay. Why? Oh, 0 to 2. Charge height. Oh. Oh, I get it now. It's because the. Okay. Let's just cancel this. Let's try it again. It's telling me that it can't do some of these because I put in the number wrong to start with. And now it's saying it doesn't work. Well, let's see here. Wow, I can't even put in 24. There we go. And then we'll just pretend this is coal. So we're going to subtract like 4 feet from that, or well, a meter from that. We'll just say it's 23. Okay, and back to our hole diameter again, because I forget what that is after I did the math already. Where are we at? 9 times 25.4. Oh, I think I did that. I think I said that wrong the last. I think I did like 52. It's 2.54 centimeters in an inch, so it's 9 times 25.4 to give us 229 millimeters. Okay, and then our resistance to blasting. I have no idea what that is, and I'm going to have to go look it up somewhere or find a research paper on it. But the default value is 2. So that gives us a burden of about 20.5 feet. Or meters. Like 20 meters? Okay, so 60 feet? Okay. This is a blasting of 1, takes that down to 10 meters. All right. So you can see that these equations can give you very different answers for very similar input parameters here. So here's the next one, Kanya's formula, which includes blast hole diameter, density of the explosive, density of the rock, and a constant. It's in here. There are several others. This one takes into account the degree of compaction, the strength by weight, another constant, inclination coefficient. So if you have inclined drill holes, so if you don't have a vertical high wall, and then spacing to burden ratio is in here as well. Pierce contains the blasting coefficient, uses the blast pressure and the tensile strength of the rock to calculate the burden. And then finally, we have what I'm going to say is Hamino. Wait a minute. Okay, well, that takes us back to empirical calculations by Ash. So there's only 6 in here because this one's in twice. Okay, so moving on to blast calculations. So if you remember, you can select a burden equation or set your burden manually. Okay. Let's go back to the burden equations. We'll do this one, 9, 80, 20, 6.83. So we did these sort of already. But here you can enter coefficients as a function of burden, diameter, or absolute value for the stemming, subdrilling, and spacing. Subdrilling is going to be 0 for doing coal here. And there's a stemming coefficient of 1. See what 0.5 does. Gives us 12. Gives us 6. Let's see if we can go about 1.5 meters. I think it's close to 4 feet of simming, subdrilling. It's going to be 0. And then the spacing coefficient, I don't know, 40 times the diameter, what they're using there, or 1.5. Sure. I need to remember. So let's check here. Okay. Well, I haven't seen that before. Let's just cancel this. Let's go back to here. And then calculation of blast parameters. These are all in meters here. So I don't know. I'm going to go back to here. We go back to this equation. So we have 8.18 meters. That's what it is in meters. There we go. So 8.18 meters. So that's set manually. And what's in our input for the empirical equation by Anderson also is that 8.18 meters. Okay. If we switch these, you'll see that these numbers change, right, based on the equation. So we're going to keep it where it was. There's default stemming coefficients in here and subdrilling and spacing. We're just going to leave those the same. You can enter data for your explosives if it's needed in the calculations. A desired production rate, 4,000 tons. Okay, I'm going to leave that in there. And the rock density, but bench height, we can change that for sure because it's in meters, but it's going to be 80 feet. So that gets us like a 24 meter bench height. Initiation number of blast holes per delay. Automatically set to 2. You can change it. Free surface faces. There's only going to be one. I mean, we're only going to have one high wall, but if you were doing like a corner or something, you could put 2 in. And then maximum number of rows. You can do it in rows and modified rows, diagonal or V-cut. You can also do the economics in here as well. Put in your explosive costs and all that, how much you're drilling, cost per meter, and that sort of thing. You can add all that in there. And then when we go to the calculation of the blast parameters, we have our initial, okay, 8.18 meters burden. That's like 25 feet. 12.27 meters spacing. I'm going to get that a little more accurate. It's 40 feet, so 40-foot spacing. This is about 25 feet of stemming. Sub-drilling, 2.45 feet, but of course, if this was coal, we're not going to do that. And then the bench height is 80 feet. Okay, so that means we have 18.3 meters of explosives in the hole. So our production target was 4,000 tons. In actuality, this design produces 6,500 tons. There's a whole bunch of other parameters in here that you can see all the way down. Powder factors in here as well. And there it is, your costs for all your stuff. You can go to the box. It says plots, but I have no idea what this means. And then here you can put in get your peak particle velocity. If you have the explosive mass per delay, so how much you're blasting per delay. The distance from the blast, two constants actually, constant K and a constant N, and that'll determine your peak particle velocities for comparison to vibration standards that are required. So these are all in here to do whatever you want with. Play around with it. See what you get, and you can also go back to the slides we did last week or the book and see how when you change the values in these equations, what that does to the burden and spacing calculations and your blasting requiremment. So with that, I'm going to sign off for this time. And we'll meet back up next time. We'll be talking about equipment sizing and, for front end loaders and truck shovel, drag lines, that sort of thing. It will all be covered next time. And so with that, have a good one, and we'll see you then.